Hello and welcome back. This is the chapter 2 of our video tutorial series for modern EFI, and in this video we will be talking about the engine performance and the components that are actually involved in making the performance of an engine higher or better or optimum. Um, but before that, we will also like to understand the functionality of a specific component in its stock form, before we move on to the performance upgrade for that specific component. So let's start with the camshaft. Okay, as we had discussed before, that in the introduction, that you have your valve train, and your valve train, a major component of that is your camshaft. Your camshaft is what actually pushes your valve up and down, causing it to open and close, in a timely fashion actually. So as you see here, this is the camshaft sprocket. This is like a chain driven camshaft sprocket. That's like you have two different types. One is chain driven, another one is belt driven. So traditionally they used to have belt chain driven camshaft, and then they moved on to something that was better, which was a belt driven camshaft. And then in recent times they are flipping back onto the chain driven camshaft, because they say that that's better again. So it's like fashion going back and forth. It has a cycle, so they can't come up with a third better way, so they keep flip-flopping every now and then. So anyway, so doesn't matter what kind of whether it's belt driven, chain driven, what you have, but it all has a similar functionality. What it does is that this cam sprocket actually rotates by a chain, and most of the Japanese, they're belt driven, like the mid racing engines like 1JZ, 2JZ, Hondas and whatnot. But the newer ones, are all chain driven engines, right? So yeah, I can say almost all. Yeah. So what happens is that this sprocket is chained to the crank of the engine, right? And this rotates along with the crank, right? And just for you to know now, this rotates at half the speed of the crank, right? This gear is half the size of your if it's half the size, it will rotate twice. Actually, it's made in such a way that it's going to rotate, so the pulley which is connected on the crank, right, that actually turns this, that has the other end of the chain, is half the size of this, not the flywheel, sorry. So anyway, so this one, it rotates at half the speed of your flywheel. Okay, why it does that, I'm gonna show you in a bit. But when this rotates, you see these lobes, right? They keep turning. So when they are facing upwards, obviously the bottom is not really bulging out. So it just passes from on top of the valve, right, without causing any push on the valve and letting it to stay closed. But when this top position actually meets the valve, obviously it's going to push it down, because this is a bulging part which has to make room, and yeah, so it has to push the valve. So that's how it works. So when it goes down, it's gonna push it down, and it's gonna, you know, cause the valve to open and then come back again. And this is all synchronized, you know, in a way that only during compression stroke the intake valve is gonna open, and exhaust stroke only the exhaust valve is gonna open. So, you know, it's almost like yeah, you're gonna see some more stuff later on. So this is your basic camshaft, right? A racing camshaft looks exactly the same because it has to seat in the same place and to be driven by the same sprocket, unless you're gonna put it, but it's the same configuration. They cannot be bigger or taller or, you know, whatever. But yeah, you do have the only thing that actually matters in a cam is your lobes, right? These are your lobes, and this is what a racing camshaft has modified actually to do it. But you can see it from your naked eye. You can't tell the difference, you know, because the differences are like how I'm gonna show you now in the next thing. So this is the lobe that we were talking about right now. Yeah, this is the one that when it keeps revolving, and when this portion comes down, obviously your valve is seated here. For example, your valve or your bucket or your push rod or whatever that thing, the thing that is responsible to open the valve is seated here, right? And it's spring forced, right? So spring loaded, sorry. So when this thing comes down, it's gonna push it down, and when it moves away from the thing, you know, the spring is gonna push it back to its place, causing it to close, right? So this is how it functions. I want to try one thing first. Where? I don't know. I wanted to try to be able to pause it. I'm gonna try it maybe later on, because sometimes people come in and then I just stop my video, and then, you know, I don't know how to. I have to still, yeah. So anyway, okay, now this one is kind of complicated, but I'm gonna spend some time here so that you know, not only for the ones who like to tune, but this is a very important part which many people do not know. Although everybody knows that, okay, why don't you buy 272? 272 is better for street and stage 1 and stage, but they don't know jack about what they're saying. Yeah, they just keep saying, yeah, 264 is like yeah. So instead of picking up bits and pieces of, you know, information from here and there, only to be able to make yourself you know, familiar with all these things and make yourself sound like a master when you talk to, you know, all these no I don't, so that's no good. You know, you have to understand, you know, it doesn't matter that only if you know one thing, but that one thing you should know in depth, you know, at least to the depth of you being able to, you know, to utilize the thing, not just hearsay from people and, you know, this is what happens and this is 272, so if you're low end and high end, then you don't know what's a low end and what's, you know, people keep saying different stuff. So let's get to this. Okay, now this is where this is the area where, you know, I wish I could draw on this. You know, I'm gonna find some other software where I would be able to draw and do stuff like that, like a whiteboard, right? So this is where your shaft is, yeah. So this area is called your base circle, right? Your base circle is something that revolves and it's not gonna disturb the cam, right? Anything above, elevated above your base circle is gonna actually push down the cam when it comes over the cam, right? So this is your base circle, right? Let's start with the left now. Okay, left is actually, I should have had something pointing here that this is your base circle, because whenever you see any diagram, you have three things: left, duration, and your base circle. So anyway, so this is your base circle, by the way. The whole diameter. Lift is how much of your valve is going to open, obviously, because till here it's flush with the thing, with the valve, right? It's not going to disturb. From this to this area is how much it's going to open. So soon as for example, now this one is 9 mm. How much is it going to open your valve? 9 mm, you know, because this is 0. When this portion comes here, it's going to push it deeper 9 mm, so your valve is going to open 9 mm. So an aftermarket cam, when you read lift 11.5, for example, they have increased this by 2.5 mm, right? So when it comes on top of your valve, it pushes it 2.5 valves deeper, so you have more air entering your cylinder, right? But there are some calculations which aftermarket people, they have to do, because you cannot go above a certain lift, otherwise you might encounter a scenario what you call as valve kissing or something like that, piston kissing, valve kissing, some bullshit like that. What it means is your valve is actually gonna touch the tip of your piston, although it might be minute, but over time, that's it. It's gonna bend the valve, or cause some damage in your piston and stuff like that. So yeah, and if it's too deep, it's gonna break in the same second. So yeah, so anyway, so all these are calculated based on your combustion chamber. You have two different types of you have interference type and you have non-interference type, and there's some bull in that. We don't want to get into that because it's going to be very, very long subject. We will never come out of it. So anyway, so your lift, what we have to understand now, leave the dangers and other stuff on the manufacturer, because we are not going to manufacture this anyway. So but the lift is when you increase the lift, you increase more air, and when you increase more air, the computer is gonna, after you tune it and stuff, it's gonna inject more gas, so you have more air fuel mixture and you produce more power because you have a bigger bang happening. So yeah, so that's the point. But there's another thing called your duration, right? Duration is what actually duration is an incomplete word or sentence. It should be duration of valve opened, so actually it means that all this time the valve is closed, logically, if you look at it, because when this portion is not actually pushing the valve, this portion is not this is not pushing, this is not pushing, this is not pushing, it starts to open it a tad bit right here. Yeah, soon as this touches it, the valve has moved down, it opens a little bit and it's fully opened here, and then it's closed here. So the opening time, the opening duration is this. Yeah, from this to this. That's simple as that. Now what you have to understand, this does not only apply to cam, but this is a generic engine statement which I would like to make here in this opportunity, is that every duration, since we are talking about duration, how do you measure a duration? Let's say, what's the duration of this test? You say 1 hour 30 minutes. What's the duration of this? Every duration is measured in time, right? But on an engine, unfortunately, we can't do that because the speed is not constant. It varies, right? So if the speed varies, the time the valve is gonna be open is gonna vary also, because speed of the crank is what is gonna move the camshaft. It's directly chain or belt driven, linked to the thing, so we cannot measure it by that. So how do we measure it? We measure it by revolution, the degree of the revolution. So everything in an engine is timed based on the degree of the crank revolution. Get it? That is how it is based. Everything, the spark timing, cam timing, and whatever it is, anything which has to be timed is based on degrees instead of milliseconds or seconds or hours or minutes or stuff like that. So this is very important to understand, that everything is based on. Okay, now when just a couple of minutes ago when I was talking about that the camshaft actually rotates at half the speed of the crankshaft. And why is that? This now I'm going to explain it to you. Because I said 4 strokes make a revolution, right? Make one cycle, not a revolution. 2 revolutions make 1 cycle. Revolutions of what? Revolutions of the flywheel, right? So when the piston goes down, your first stroke, that's your compression stroke, right? When the piston goes down and sucks in the mixture, right, the flywheel has moved, boom, 180 degrees, right? Because if you look at the crankshaft, I'm trying to make some gestures with my hand as though you can see it. When the crankshaft is like a 4-cylinder, for example, is 180 degree apart of 2 connecting rods connecting on a crankshaft is 180 degree apart, right? So when this pushes it down, that goes full up. When that goes full down, this goes full up. So you have like a, what do you call it? Like a drummer, drumming, one hand up and another down and stuff like that. So that kind of a thing. So it's always 180 degree apart, right? So a stroke, the piston moves down, causing this one to turn from here till there. Then the piston goes up to compress, causing the thing to go back to its place, which is 360 degrees, right? So this is 1 revolution. Then the piston goes down again because of power stroke. When the the spark happens, boom, and it goes here. Then the piston goes up again, which is another 180 degree, and throws out your exhaust, right? But the cam has to open the valve only once during 2 cycles, 2 strokes, right? That is why it has been made to rotate at half the speed, because when the suction is happening, the valve is open, right? And the cam has spun half. So this is where the valve is open and it closes, almost here somewhere. And then when the piston is coming up, the cam lobe is facing like this. It's already going up. It's away from the valve, right? So it's going up. So this is why a complete revolution of a cam happens in 4 strokes, right? Which means in 2 revolutions of the engine. If you don't understand that further, you might want to read something more or watch YouTube videos and stuff like that. Yeah. So this is how it is timed, right? Okay. So since this is timed based on the revolution degree, yeah, of the crank position, we are going to talk about degrees here, right? So generally this will be 0 degree, and this goes 180 degree, and when it closes here it's 360 degree. But in a camshaft, this is gonna be 360 degrees. Why? Because I told you this is 360 degree of the crank. We always measure on the crank degree. We don't measure like on a camshaft degree or whatever, right? So this is 360 degree of, because I told you that this rotates at half the speed, and this is 72 degrees, right? Okay, so, sorry, 720 degrees. Yeah. So if this is 360, this is 180, right? This is 180. And what's half of 180? That's 90, right? Okay. So let's say this is 100. Okay. So if this is 100, 720 minus 100 is 620, right? Yeah, 620. So 620, so 100 plus 100, this is like a 200 degree duration. Sorry, from here to here there's like 100 degree, and from here to here there's like 100 degree. So the total duration is 200 degree of this camshaft, roughly. If you measure it, it's gonna be somewhere close to it, 200 or 210, right? So what happens is, when you buy a racing cam, right, when you say it's stage 1 232, they push this down slightly here. They start opening the cam like this. They make this area slightly wider. Okay, so this is your stage 1, you know. So it pushes the valve before and closes the valve slightly after. Okay, slightly after it closes and slightly before it opens. When you go 272, it comes all the way till here, for example, right? You can measure it easy. You can do your own math, you know. So, and it goes like that. But it meets whatever lift it's advertising. It's not going to go like all the way here. Like, so sometimes you might even have the same lift, but it's wider only. You know, some areas they want to make like custom, I don't know if it works for them or not, but there are many people who want to make custom stuff. And this is what, when you say custom, you're going to mention, you know, I want this duration and this and this. So they do it for you. They don't give a damn. You can say, open it earlier, right? Open it earlier, but close it here. You can say that. They can do that for you, right? So all that is nonsense. I don't know. But you know, I don't know how much you gain, but you take a lot of headache, and you know, just go with the aftermarket, ready, off the shelf. And you know, some people like to sit with binoculars and, you know, or microscopes and look in the, no, it's not really in, you know, if the shift happens slightly, like a fraction of a second later, you can lose or you know, your tires did not do proper traction, you're gonna lose, you know, all that camshaft timing and all that, you know. Yeah, so yeah, like going from 232 to 272, it's gonna make a big difference. But you know, going with 1 millisecond here and there, I don't know, I don't care much about that anyway. I'm not here to criticize, you know, other people's work and stuff like that, but you know, just when you are an amateur, don't try to be an expert. That's all what I'm saying. If you read somewhere, no, you know, this makes a big difference, and you don't know why it makes a big difference, but you want to go, and when your friend is, you want to be the smart guy and say, you know, no, don't buy this because, you know, it makes a difference. And when he asks you why, you don't know how to explain, but you want to say that, you know, I read it on. Don't do that, you know. Just you know, don't try to go to a doctor and act like, you know everything. It's annoying. So anyway, so now I think we've understood that how this thing works, right? The lift and the this and the that and the other thing, right? There's one thing which I would want to bring also to your attention, is that, okay, if you increase the lift, you're not gonna have any problem, except that like I told you, the valve should not be pushed more than, you know, its capacity and stuff like that. That's as basic as that. But when it comes to duration, right, what's gonna happen is that when you open before, okay, what happens? I will remind you, the first stroke is suction and the last stroke is exhaust, right? So let's say your exhaust stroke, the piston has still not come to its top dead center, right? Because the stock has timed this correctly to open exactly after the exhaust valve has closed, right? What happens is when you make this to open early, what happens is that your exhaust, it has still not closed and your intake has started to open before this much of time, right? So what's gonna happen? Your exhaust, since it's in the same cylinder, some of it is gonna come into your intake, right? Because your exhaust has also a good pressure. The piston is pushing it out and exhaust valve is open, but at the same time your intake valve is also open. So what's going to happen is your exhaust is going to go into your fresh air inside the intake, right? This is why you have rough idling. And especially when your engine is idling or it's at low RPM, it does not have too much of vacuum going on, right? Intake is not so much pressurized, so it cannot push the exhaust back, or it cannot keep the exhaust gas from coming into the intake. So exhaust actually goes into the intake, and it might even, if it's too much, it's gonna start exploding inside the intake. It's gonna ignite inside the intake. That's why sometimes when you have a wrong timing and stuff like that, you hear this backfiring from the intake and stuff like that. That's your fresh air entering your intake. So what's gonna happen is when this exhaust gases go inside that, you see that the your car is a bit rough and stuff like that, and also the lift causes that, but that's something we don't want to get into. It's very technical, but this is what happens, right? That I would not care much about, because if you are a performance freak and your main goal is to get, why do you think that the factories did not think of that? Let's make it 272, let's make it 282. Why couldn't they do that? To give you more power. Because a factory has to think from all dimensions, and their objective is, the first priority is to give you a smooth thing with efficiency and this, and the last thing is what they look at as the power. So especially in the non depends on what kind of what kind of car that is. If you're buying a sports car, then they have to give certain priority to the power and stuff without compromising much on the other side. But we can compromise, actually. We can compromise when we are building a race car and stuff like that. So we can say, we don't care about that smoothness, we don't care about so that's when we can bring it down here. But what happens is, if this is causing this non-behavior, which is against the benefit of, why do we do it? Why do you want the exhaust gas to go in there? It's because what happens is when the rev goes beyond let's say 3 to 4, 5,000, depending on what car you have, the engine is actually producing enough vacuum and enough pressure that the exhaust is escaping, like that, for example, right? It keeps escaping. So when the exhaust is escaping, right, it is actually causing a vacuum. It's causing, because the air is flowing this direction. This is all aerodynamics, right? When the air is flowing at a higher rate, it will cause suction, it will cause vacuum. It's higher than this, and the whole momentum is going like that. So it actually helps in sucking in more air from your intake. Get it? Plus, you had more time to allow more air to come in. And similarly, when this thing, the compression closes later, right? Even though the piston is now on the power stroke, but the pressure of the air in the intake is so much that, you know, right at the beginning of the next stroke, when the piston is coming up, it does not, the pressure of the intake is greater than the pressure of this, so it can still enter more air, you know, something to that effect, you know. So the bottom line is, in the higher rev, these cams are gonna do a very beautiful job, right? They're gonna give you very big gains, not like the, you know, those cheap as headers and, you know, filter and stuff like that on a 4-cylinder and stuff like that. No, not like that. Cams give you very massive gains, right? But yeah, you have to give it proper fueling and stuff like that, and that's something else that we want to increase the air, CFM, right? So how do we do it without a forced induction? You know, that's how we do it. So I hope that I've covered, you know. So yeah, one thing, when you have this area opening, when the exhaust is also open, you know, from the other cam lobe, that is called the overlap, you know. So when you read the cam specs, overlap this many degrees, that means for this many degrees you will be having that is when both of the exhaust and intake valves are going to be open. They're going to stay open for that short duration. And obviously, like I told you, the duration, every duration is measured by a degree. It can be measured by milliseconds or seconds or time based, right? So I think I've covered enough here in the camshaft. Yeah, because this is the most complicated stuff. Everything else is simple. So I thought I'll cover this so everybody else also can benefit from this, and, you know, even whether you're tuning or not, but this is what the bottom line is. Okay, now something, you know, yeah, now since we have covered all that racing performance cam and all, this thing is supposed to be easier. You know, the VTec, you know, when you have dual cam profile on, you have it in Honda, you have it in Toyota, Nissan, Mazda, and almost, you know, every you don't have this on the LS engines and stuff like that. They don't want to care. They just want to stick to their traditional stuff, and yeah, they're cool with that. I think Ford has it. I'm not sure. But anyway, so what this does is, you know, like I told you, the pros and cons of the aftermarket cams was that at lower RPM, or especially when you're idling, the overlap is actually not so good, and, you know, it takes away your comfort. So OEM was struggling to make a camshaft, you know, but, you know, like I told you before, that they will not compromise with the quality or the, you know, smoothness and comfort and all that both. So they said, how can we give you best of both the worlds, right? So this is what they came up with, right? This is, as you can see, your smaller lift and smaller duration, smaller profile, okay? This is your bigger profile, right? And this is your twin cam, right? I mean, 2 lobes for 2 valves, right? Shit, I didn't speak about twin cam and all that, but, you know, I don't care about that. I think most of you know, so I'm not gonna waste my time about it, or read on YouTube what it says, you know. So I mean, read on Wikipedia and watch YouTube or whatever. So yeah, so what this does is, you see, when your cam, in this scenario, when your cam rotates, it pushes this thing up and down, okay? When it goes up, this goes down, pushing the valve to open, right? So when it moves away from it, you know, this is up, it's pushing the valve down. So when it moves away from it, this is going to come down and bring the valve up and close it, right? Okay. So what happens? When the VTec engages, this is when it's on a low RPM and stuff like that on a factory. So let's say this is like your 200 duration cam, right? What happens is when your VTec engages, right? When your VTec is turned on by the computer, there's a solenoid which allows the engine oil, because engine oil is always in pressure, right, to push this rod, right, inside it. Okay, it pushes this rod and it engages this. You get it? So what happens now? All this, everything is connected together, so this thing takes over, right? Because this is the highest it can go. So it forces these two valves to actually work according to this lobe, and these lobes are, you know, good for nothing, you know, just sitting there like, you know, I don't know. So yeah, so when the RPM drops again, this thing disengages and this lobe takes control again. So you get it? So that way you get best of both worlds. So here you have 200, and when the VTec engages, you know, the 272 or whatever, you know, takes over, right, with whatever lift they have and stuff like that. So you know, the good thing about this is, like, on a low idling, they can actually even go even smaller, you know, they can go even smaller, so you have better efficiency and more smooth than nothing, you know. Yeah, I mean, the non-VTec engines, they have to slightly give up on the fuel efficiency and stuff, because they don't want to kill your power, everything. But in this, they can kill all your power in a low profile cam. They don't care. But on your high profile, you know, that's what happens, you know, you have everything. So well, since you're gonna be you know, switching almost always to your high profile when you step on it, why care about the low profile? That's the thing, that's the thinking, and that's why this is a very nice thing. Okay, now let's move on to VVTI. My God, I shouldn't have even brought this here. This is gonna be so complicated, right? Okay, there's one thing they call as degreeing a cam. You know, many of you have heard it and stuff like that. And degreeing a cam is actually manually, you know, man, I don't know why I brought this up, but yeah, a camshaft, like I told you, is belt driven and it's connected, or chain driven is connected to your crank, right? And I told you that it is calibrated in certain way, it's synchronized in certain way, that it opens exactly when the piston goes up on cylinder number 1, this has to open, this valve has to open, and when it goes down, that valve has to close. So yeah, so a camshaft is designed in a certain way, right? What you can do is you can actually turn the cam sprocket and cause it to, they call it advance it a bit. That means open beforehand slightly. Like I told you, you know, the benefits of a valve opening slightly before is that you have rough idle, but you have a better thing on the top end. So you can also do it on your stock cams, right? You can actually cause it to open slightly before, but it's gonna close also slightly before. Remember that, right? Because your duration did not increase, it's the same duration. So when you make it to open slightly earlier, it's gonna close slightly earlier. So you have to choose the best thing that's working out for you, right? And when you play with it, some people, they play with the exhaust thing to close or open or whatever slightly earlier. So yeah, so it works for them, right? And it gives you power. So let's just understand that much. I think that's enough. So VVTI, again, gives you best of both worlds in that, messing around with the cam timing. VTI can constantly turn your sprocket. Just think of it like a guy sitting there with his spanners, and you keep telling him, okay, make it 2-degree advance, make it 4-degree retard, and that's what you have the power. There's a solenoid which flows oil, and the oil goes from in this and comes out from here, and so ultimately what it does is it advances or delays or retards your valve opening. So let's say on idling, I don't want it to open beforehand, obviously, right? Because idling, if it opens beforehand, my exhaust gas is going to go in my intake, and it's going to cause that whatever misfiring kind of a thing, and roughness, and causing heat, and so many other things. So this gives me best of both worlds in that dimension, right? That my cam stays, my valve stays closed, but soon as I push on it, it advances it because there's a huge vacuum. So it advances the thing and it lets the valve open beforehand, and gives me a lot of torque. And but on the higher end, again, what happens is the pressure inside cylinder and intake starts to become equal, and stuff like that. I don't know much about that also, like those are again physics and stuff. So you do not need any advance then, or you need like slightly very less advance so it retards it back again, and so it keeps playing with that, and you can actually tune this when you're tuning, and you can go against the, you can utilize it even further, and do what you got to do, because when you have larger cams and stuff like that, maybe you would want to not stick with the factory thing, and or you might want to just go a bit more aggressive and compromise on your, like factory, for example, it gives you full advance on 3000 instead of 2.5. Let's say 2.5, you can still make significant gains, but you still feel that vibration, because so that's why they delay it a bit to get best of both worlds. But what you can do is you can actually be a bit aggressive and say, I don't care about that vibration, I'm just gonna advance it now, and that's how you do it. Yeah. So so much for that VVTI, and yeah, I think we have covered this. Okay, now this is the cam timing, right? I am very tired now. Want to take a break, so I think I'm gonna just close this thing very quickly. Cam timing, as you can see, like I told you, that all the lobes have to be aligned in certain way, that when the piston is on top, the valve is not open, and the piston which is down, that valve should start to open and different stroke and stuff like that. So how do you do that? So you see, this is the thing which drives the cam, right? If you want to count the teeth, this will be half of that, right? This is exactly half. So if this is 24, this is 48, right? And that's how this thing's, always the shorter gear is rotating at higher speed than the than the bigger gear, right? The smaller gear is always going faster. Yeah. I once had this argument with one idiot, and it took me like, he would not, I don't know, even though no matter how much I would draw on the paper and show him a bicycle, show him what, he would not want to, Anyway, so as you can see, this on the timing cover, you have two markings, right? Timing, you see those notches there, those embossed kind of a thing that's bulging out. Those are your markings, right? And in this particular sprocket, you see there's a thing for a dowel pin, right? So your dowel pin is gonna go only in one, let's not even talk about it. Yeah. So it's gonna be very confusing. So this is your cam, and this is your crank. Crank has a certain notch here also. I think it's this one. Yeah, this is your notch. So you have to match this to this, right, and this to that, and then put the belt on and tighten it up, and that's when you have your timing correct. If you are missing, if you are off even one tooth, you know what's going to happen. Your intake is going to open a couple of degrees earlier, and exhaust is going to open or close or whatever, and it's going to cause all that stupid thing happening, right? But you can see that in this sprocket you can't adjust your advance and thing, because yeah, let's say I can make it one tooth off, but one tooth is too much. It's too many degrees. You can't have it. So that's why you need the aftermarket sprockets, because it just lets you go a tad bit of the thing, which is like already a couple of degrees. So that's what you want, right? That's the purpose of the aftermarket cam sprockets, other than, you know, to fool people that, you know, your engine is completely built if you want it that way. Yeah. Now this is a Dyno Graph, right? We're going to be talking more about the Dyno Graph and trying to understand how it works and stuff like that. But let's take it very quick, right? This is from an American engine. You know why I brought an American engine? Because it performs, you know, it responds so well to a camshaft that you will not believe, right? So this was your stock, the blue, right? The blue horsepower. Blue, yeah, I mean the stock horsepower is your blue thing, right? So you can see what was your max horsepower. Can you see it? It was 352, let's say, right? This is 352 was your max horsepower, right? And it dropped back to 300 in the end, right? So you are having 352 only for between, let's say, 4.5 to 6. You know, you're having like an average of 330. You have it. But when you when this guy installed a small cam, also not really a big cam, I think, right? Look at what he gained. His max horsepower is 440. From 352 to 440, that's 90 horsepower gain in a 5.3. And it's not actually dropping, right? You see? It's just slightly dropped before the rev limit. And where this had at, let's say, at 4,500, this was still not 350 or 352, whatever the max power it was, right? This the performance cam was already above 360 or something like that. So not only you get bigger horsepower, you get it early also. You see this? Yeah. This is the deviation here. Till here, as though you had no cams. Till 4,000, right? 4,200. As though it was the same. No difference, right? Stock and all, no difference. But what you want to see is that below 2,800, you see, you have very less power, right, compared to the, but you don't need that power here. But this is like a sign of that. This is the side effect of large camshafts, right? Like I told you, the exhaust going into the intake and stuff like that, that overlap causes you to lose power here. In the torque you can see a big difference, right? This is yeah, but look at how the torque jumps here, right? Jumps, like where it starts to fall, you know, where it starts to give up, it's actually jumping and giving you all that power. Yeah, so that's camshaft, no joke, baby. This is 90 horsepower, right? So yeah, which is almost like 300 to 400 is like 30% gain, I think, which is very nice. Okay, for some people might be complaining that, you know what, you have to bring an American engine and show us the American engine and stuff like that. So I brought, this is like a 1JZ or 2JZ or some bull, right? But you see that the reason why I like to bring American is that because the Japanese don't make that much power with the things, right? With camshafts like Americans do. So yeah, anyway, so here let's look at it. The OE, right? This is all horsepower. The OE is stock, right? So you can see stock is doing a very good job. The black is always above everybody else. It's above everybody else. It's above everybody else. It's above, but here it starts. The blue is matching it, you know, just like almost at 4,000 RPM. The blue is actually matching it, and at 5,000 RPM you see that the blue is already taken over, right? And 6,000, that's it, blue is in another country altogether, right? Stock is way down. And then you see at 7, stock has died big time, but you know, the blue maintained till 6.5, right? And at 7. So now you would be shocked to know that the worst performance was OE, stock, right? And the next was 256. And then the next was 272. So you see 272 was doing way lot worse. Like look here, it's the worst out of all of them, right? But here, okay, yeah, it's matching, and still even at the top end, no. But 264 was doing a very good job, right? And that's the reality when it comes to, yeah. And this is not for a close to stock 1JZ, no. We are talking about 550 horsepower. So you don't need 272, you know. You actually need 264. 264C does a very good job. But you know what? We don't give a damn about no 264 and all that. We want to hear that song, you know. We want to hear the cam cussing back at us, you know. We want to hear that, what we call as hadra, you know. We want to hear that thing. That's a very good music. So we want that rough idle. So that's why we deliberately put 272. You know, we want to hear that thing talking back to us, you know, giving us that main, you know, thing. So that's why 272 is good enough for us. And you know, if you do a valve job, I think this is gonna improve on a 272. But yeah, the ones who are serious, you know, they want serious cars and stuff like that, and they want best and everything, go for 264. Yeah, you can see the result. Judge by the results. Okay, so much for that, and I think I'm done. I hope there's no other slides remaining, and that's it. I think I think I've covered like camshaft quite extensively. So yeah, other things are not going to take so much time. That's why this is just the first part of chapter 2, but I am dedicating a whole video for this section so that, you know, anybody else can just jump into this video and learn about camshafts. Hopefully, you know, you guys learn from this, and yeah, thank you very much.